Okay. I would like to show you how to evaluate powers in this video. Powers are evaluated. So here, powers are evaluated by performing the indicated multiplication in the expanded form. If you remember, a power can be expressed in two forms: the expanded notation and the exponential notation. So in the expanded notation, we show what's inside, so to speak, of the exponential notation. Let's try this example. Evaluate 3 to the 4th power. First, we have to change 3 to the 4th power to the expanded notation. Here we have it in exponential notation. We show 1 3 with a little 4 on top. That's the exponent, showing what is repeated 4 times in multiplication. So we show the 3 in the expanded notation. We write the 3 4 times as a factor. Now remember that a factor is nothing more than either a multiplier or the multiplicand. Okay, and we show it 4 times because we have a 4 on top of the 3. Okay, and so here we are showing multiply 3 times 3 times 3 times 3. Okay, to perform the multiplication, then we start with the left, the 3's on the left. 3 times 3 gives me a 9, although it doesn't matter how you multiply it. For instance, you could also multiply the other 3 times 3 as well. Okay, now once you have the product, the result of 3 times 3, now multiply times the next 3. Okay, and now 9 times 3 is 27. And now we just have one more 3 to multiply. So we take 27 and multiply it now times 3. We can do the multiplication here on the side. 27 times 3. We write, now we multiply 3 times 7 is 21 and carry a 2, and 3 times 2 is 6 plus 2 is 8. So 27 times 3 gives us 81. This is what we call the value of the power. 3 to the 4th power has a value of 81. Okay. Now I'm going to say this now, but I'm going to repeat it over and over in each example. 3 to the 4th power is not 3 times 4. Okay, 3 to the 4th power is not equal to 3 times 4. Okay, it's easy to think that that might be the case, but that's not the case. This means not equal, by the way. An equal sign written with a slash across it means not equal. So why is this not equal? Because 3 times 4 is multiplication of the 3 4 times, where, I'm sorry, 3 to the 4th power is multiplication of the 3 4 times. But 3 times 4 is actually addition of 3 4 times. We add 3 plus 3 plus 3 plus 3. If we do the addition, this will give me a 9 plus 6 plus 3 will give me a 9 plus 3 will give me a 12. This answer is not the same as 81. 81 comes from multiplying. 12 comes from adding. So 12 is much smaller than 81. So remember, it's not the same thing as 3 times 4 or 4 times 3, either way. It is 3 times 3 times 3 times 3. Now let me say this in Spanish. Quiero explicar ahora cómo sacar el valor de una potencia. Siendo que las potencias muestran una multiplicación repetida, entonces aquí lo que tenemos que hacer es una multiplicación. Vamos a multiplicar repetidamente el mismo número. So aquí dice, las potencias se evalúan al hacer la multiplicación indicada en la forma extendida. Si ustedes recuerdan, las potencias se pueden expresar en dos formas. La forma extendida, esta es la forma extendida, extended. Y esta es la forma, la forma exponencial, exponential. ¿Ok? En la forma exponencial mostramos nada más solamente un 3, que es la base, con un 4 chiquito subido arriba. Y eso indica que hay 4 treses que están multiplicados juntos. El 3 se repite 4 veces como factor. 3 por 3 es 9, 9 por 3 es 27, y luego 27 por 3 es 81. Y aquí si quieren pueden ver la multiplicación. 3 por 7 es 21 y van 2. 3 por 2, 6 y 2, 8. Aquí quiero advertir que 3 subido a la potencia 4 no es 3 por 4. Ese sería un error. 3 por 4 es 3 más 3 más 3 más 3. Esa es una suma repetida. Pero esto es una multiplicación repetida. La multiplicación repetida da un resultado mucho más grande que la suma repetida. Ok, so hay que tener cuidado. Y este es el signo del no igual. Ok. So now I'd like to move on to the next example. In the next example, we are looking at evaluating 21 to the third power. So again, here we are showing the exponential notation, which shows 21 raised to the third power. It shows the base is 21 and 3 is the exponent. And this, in expanded form, would be 21 multiplied times 21 multiplied times 21. Oops. Okay, 3 times. That's what the 3 is telling us. It says write the 21 as a factor 3 times. Okay, now we move on to do the multiplication. So first we multiply 21 times 21. So write 21 times 21 on the side. First with 1. 1 times 1 is 1. 1 times 2 is 2. Now with 2, 2 times 1 is 2, and 2 times 2 is 4. Now we add the partial product, so we get 1, 4, and 4. So multiplying 21 times 21 gives us 441. Now I multiply times the next 21. And let's do the multiplication here on the side. 441, which is this result, times 21. Okay, now 1 times 1 is 1, 1 times 4 is 4, and 1 times 4 is 4. Now I multiply with 2. 2 times 1 is 2, 2 times 4 is 8, and 2 times 4 is 8. We add the 2 partial products, we get 1, 6, 4 and 8 is 12, and we carry a 1, and this gives us 9,261. So multiplying these two together will give us 9,261. So now we can say that 21 raised to the third power has a value of 9,000. 261. That's the value of the power. Okay, so again, let me say this again. 21 raised to the third power is not 21 times 3. 21 times 3 is a very different animal. It's 21 plus 21 plus 21. Whereas 21 to the third power is 21 times 21 times 21. Okay, so once that is clear in your mind, I think you would have no problem evaluating a power. Okay, now let's look at some powers that have somewhat unexpected values. So let's try to evaluate 1 to the 6th power. Again, I write the exponential, this is the exponential form, and now I show it in expanded form. In expanded form, this would be 1 times 1 repeated 6 times, 4 times, 5 times, 6 times. So here I'm multiplying a 1 times itself. 1 times 1 times 1 times 1 times 1 times 1. And so what do you think it's gonna be? Well, first, 1 times 1 would simply give me a 1. Now I multiply times the third one, and it gives me another 1. Times the fourth one, and it gives me another 1. Times the 5th one will give me another 1. Times the 6th one will give me another 1. If you were thinking that this ought to give me a 6, then you would be incorrect. 1 to the 6th power is not 1 plus 1 plus 1 plus 1 plus 1 plus 1. It's 1 times 1 times 1, and so on. And if you do the multiplying, you will simply get a 1. That's because any time we multiply any number, say A, times 1, we get back the same A. So if A is just a 1, then 1 times 1 would also be a 1. But if A is a 2, then 2 times 1 would be 2. 3 times 1 will be 3, and so on. So let's see, what would 1 raised to the 10th power be? Without doing any multiplying in your head, you can say that is simply just a 1. 1 raised to any number, in fact. But any n, let's call it n being a positive integer, a whole number or a natural number. Okay? If n is like 1 or 2 or 3 or 4 or 5, bigger than 0, okay, then 1 to the nth power is going to be a 1. Now let's look at another example that might also throw you off. Here we have 0 to the 5th power. Okay, I'm going to finish this in English and then I'll return and do it in Spanish. 0 to the 5th power. If I write this in expanded form, I will write 0 times 0 times 0 times 0 times 0. 5 zeros multiplied together. Okay, if we do the multiplying, we get 0 times the next 0 would give me another 0 times the next 0 would give me another 0 times the next 0 would give me another 0. No matter how many zeros I multiply together, I will always get 0. So again, 0 raised to any power as long as n is a positive integer, okay? Positive number greater than 1, greater than 0, okay? Then I'm going to have a 0. Okay, now just very quickly, let's look at some other powers, especially like a a power raised to the 1. So I have 6 raised to the 1 power. Since the 6 appears only one time in the expanded form, then that's my answer. So any number, say 8 raised to the 1 power, is going to be the number itself. 48 raised to the 1 power is going to be simply 48. So any number, say a raised to the 1 power, is going to be just a. Okay, and this is true for any a. Okay, so then we're done with this video, and I'm going to repeat this in Spanish. Aquí estaba viendo cómo sacar las potencias del 21 a la tercera potencia en este ejemplo. So, escribimos la notación extendida que nos da 21 por 21 por 21. O sea, escribimos el 21 3 veces. Ese es el 3 chiquito que vemos aquí. Eso es lo que nos dice. Pone el 21 3 veces como factor. Y ahora vamos a hacer la multiplicación. Como estamos multiplicando, empezamos con el 21 por 21. So, aquí nos da 1 por 1 es 1, 1 por 2 es 2. 2 por 1 es 2 y 2 por 2 es 4. Sumamos hacemos la suma de los productos parciales y nos da 1, 4, 4. Sacamos 441. Ahora por el último 21, sacamos aquí 1 por 1 es 1, 1 por 4 es 4, 1 por 4 es 4. Ahora por el 2. 2 por 1, 2, 2 por 4, 8 y 2 por 4, 8. Sumo los productos parciales y me da 1, 6, 12 y va 1, 1 y 8, 9. Eso viene saliendo 9,261. ¿Okay? So, aquí tengo el 21 subido a la potencia 3, que el valor viene saliendo 9,261. Otra vez quiero advertir que el 21 a la potencia de 3 no es 21 por 3. 21 por 3 sería un número más pequeño, porque ahí estaríamos sumando el 21 3 veces. Pero aquí lo estamos multiplicando 3 veces por sí mismo. ¿Okay? Ahora vemos el tercer ejemplo. En este ejemplo queremos ver algunas potencias un poquito extrañas. Por ejemplo, aquí tenemos el 1 subido a la potencia de 6. Y en la forma extendida, escribimos 1 por 1 por 1 por 1 6 veces. ¿Okay? Pero al multiplicar, sacamos que 1 por 1 es nada más 1 por 1, 1 por 1, 1 por 1, 1 y por 1, 1. So, el resultado sale solamente 1. Si ustedes estaban pensando que debería de haber sido 6, estarían incorrectos, porque esta no es la suma, sino la multiplicación. So, esta es una excepción porque siempre esperamos que la multiplicación salga más grande, pero aquí sale a 1. La suma sale más grande, porque si sumo 1 más 1 más 1 más 1 me da 6. Okay. Esta es la multiplicación. So, el 1 subido a cualquier exponente nos va a dar 1, porque no importa que tantos unos multiplique juntos, siempre me va a dar 1. Cualquier número que multiplique por el 1 me da el número mismo. Esa es la regla que estamos viendo. Entonces aquí 1 subido a cualquier potencia, no tiene que ser 6 o 10, cualquier potencia, siendo un número positivo mayor que 0, nos va a dar un 1. ¿Okay? Vamos a ver ahora también una potencia de 0. Las potencias de 0 siempre nos van nos van a dar 0. 0 multiplicado por sí mismo 5 veces me va a dar 0, porque 0 por 0 es 0. 0 por cualquier número siempre es 0. Entonces este me va a dar un montón de ceros multiplicados juntos, me da 0. 0 a la potencia n, no importa que n sea, siendo un número positivo mayor que 0, si el exponente es positivo, entonces decimos que 0 a la potencia n es 0. Este es otro ejemplo. Este sería ejemplos de la potencia, números subidos a la potencia 1. Cuando el exponente es un 1, siempre da el mismo número, porque eso indica que este se está repitiendo solamente una vez. 6 a la potencia 1 sería nada más 6. 8 a la potencia 1 sería solamente 8. 48 a la potencia 1 sería solamente 48. Cualquier número subido a la potencia 1 sería el mismo número. Y aquí se termina este video. En el próximo video vamos a ver potencias de otros números como los números negativos. In the next video, we're going to talk about powers where the base is negative, like say a negative 3, say raised to the 5th power, or something like that. Or a negative or a fraction base. If I have a fractional base like 2/3, I can raise it to a certain power, like for instance the power of 2. So we're going to be looking at these kinds of powers, okay, in the next video.